In the 19th century, cities built structures that would challenge modern construction. Entire districts rose from stone and brick. Massive buildings appeared in a matter of years. Railways, bridges, tunnels, and civic monuments transformed landscapes at an unprecedented scale. All of this happened before electricity, before modern cranes, before diesel engines or hydraulic machinery. According to history, these projects were completed using manual labor, basic tools, and limited mechanical assistance. And yet, the results still stand today. The size is difficult to ignore, the precision is hard to dismiss, and the speed raises questions. This is not about whether people in the 1800s were capable. They clearly were. The question is whether the scale of what they built aligns with the tools, logistics, and timelines we assume they had. Because when we begin to measure the volume of material, the coordination required, and the time frames involved, something feels compressed. Not impossible, but surprisingly efficient. So, before we accept familiar explanations, it's worth stepping back and asking a simpler question. How did cities in the 1800s build so much, so quickly, with so little technology? The official explanation focuses on human effort, large workforces, long hours, manual labor on an enormous scale. In the 19th century, cities attracted waves of workers, immigrants, laborers, craftsmen. With enough people, the argument goes, almost anything is possible. Steam power also played a role. Early steam engines assisted with lifting, pumping, and transport. Canals and railways moved materials over long distances. Combined, these factors are said to explain the construction boom of the era. On paper, it sounds convincing. More people, more time, more effort. But when the numbers are examined more closely, the explanation begins to strain. Consider the amount of stone required for a single large civic building. Thousands of tons, quarried, cut, transported, assembled. Now multiply that by dozens of buildings, often constructed simultaneously in the same city. All while streets remained active, commerce continued, and daily life went on. The official narrative assumes unlimited labor and uninterrupted progress, but historical records show frequent shortages, economic downturns, labor disputes, supply constraints. Construction was not happening in ideal conditions. Another assumption is skill. Many 19th century buildings feature intricate stonework, precise alignment, and standardized components. This level of craftsmanship requires training, experience, and coordination. Skilled labor cannot simply be multiplied overnight. It takes time to train artisans, time to standardize methods, time to achieve consistency at scale. Yet, entire neighborhoods display near-identical architectural elements produced within narrow time windows. The narrative also relies heavily on gradual progress, decades of work, slow accumulation. But in many cases, documented construction timelines are surprisingly short. Buildings of immense size appear to rise in 5, 10, or 15 years, not generations. This does not invalidate the official explanation, but it does suggest that something is missing from it. Human effort explains how work was done. It does not fully explain how much was done and how fast. And once that gap is recognized, the scale itself becomes the question. Once we move past general explanations, the problem becomes mathematical. Scale. 19th century cities did not build one or two monumental structures. They built many, often at the same time. Entire civic centers, rail terminals, universities, hospitals, government buildings, each constructed primarily from stone and brick. To understand the scale, consider a single large stone building. Thousands of tons of material had to be quarried, each block cut to specification, each piece transported, often over long distances, then lifted, aligned, and set with precision. Now, multiply that by dozens of structures rising simultaneously within the same decade. The numbers escalate quickly. Millions of bricks, hundreds of thousands of stone blocks, kilometers of masonry. This is not abstract. Every block represents time. Every ton represents labor. Every movement represents coordination. The challenge is not that this work was impossible. It is that it was compressed. In many cities, construction records show multiple large projects overlapping. Streets remained open. Trade continued. Populations grew. Cities did not pause to build. They expanded while building. This creates a logistical bottleneck. Material must arrive at the right place, at the right time, in the right quantity. Workers must be scheduled. Skilled labor must be allocated efficiently. Delays ripple outward. Yet, many projects progressed with remarkable consistency. Another factor is waste. Stone cutting produces debris. Brick production requires fuel. Transport generates loss. These inefficiencies compound at scale. But historical timelines often leave little room for inefficiency. Buildings described as completed appear structurally finished, not partially realized. They do not look like work in progress. This suggests a level of throughput that rivals modern construction, which raises an uncomfortable comparison. Today, similar projects require heavy machinery, digital planning, and global supply chains. They involve months of preparatory work before construction even begins. And yet, the 19th century equivalents moved forward with tools and methods we consider limited. The scale problem does not argue that people in the past were less capable. It argues that the scope of what they achieved challenges our assumptions about pace and organization. At some point, volume stops being a question of effort and becomes a question of system. Systems scale work. They reduce friction. They standardize processes. They allow repetition without loss of quality. And the output we see from the 19th century suggests the presence of such systems, even if they are not fully described in the historical record. This does not mean we are missing secret technology. It means we may be underestimating how coordinated construction already was, or overlooking inherited processes that made large-scale building more efficient than we assume. The buildings themselves are the evidence. They represent work completed, not imagined. And when the volume of that work is considered honestly, the question becomes unavoidable. What kind of organizational capacity makes this scale possible? Once scale is acknowledged, the next problem becomes unavoidable. Movement. Stone does not move itself. Bricks do not appear on site by accident. Steel, timber, and glass must be transported, often over long distances, before construction can even begin. In the 19th century, this movement was slow. Horse-drawn wagons dominated land transport. Each wagon could carry only a limited load. Road conditions were inconsistent, seasonal, and often poor. Canals offered greater capacity, but they required specific routes and careful timing. Railways expanded rapidly, but even they relied on loading, unloading, and secondary transport to reach construction sites. Every stage introduced delay. Now, consider the quantities involved. Thousands of tons of stone, millions of bricks, entire shipments of timber and metal. And to move this volume through narrow city streets, while cities remained active, required precise coordination. And yet, many 19th century construction sites appear remarkably orderly in photographs. Materials are stacked systematically. Streets around them remain passable. Daily life continues. This suggests planning far beyond improvisation. Another complication is distance. Stone was often quarried far from the city where it was used. Brick kilns were located near clay sources, not construction sites. Timber traveled from forests hundreds of kilometers away. Each material followed a different route. Each route required synchronization. Delays in one supply chain would halt work across an entire site. But construction timelines suggest continuity. Buildings did not stall halfway through, and they progressed steadily toward completion. This implies buffers, storage capacity, predictable scheduling, all features of a mature logistical system. The use of canals and railways certainly helped, but infrastructure alone does not guarantee efficiency. Someone had to design routes, allocate resources, coordinate labor with deliveries. This level of logistics is comparable to modern supply chains, though executed without digital tracking, instant communication, or automation. Another factor often overlooked is return transport. Wagons do not simply arrive full, they must leave empty. Canals require balanced traffic to remain efficient. Managing return flow adds another layer of complexity. Yet, historical accounts rarely describe widespread transport chaos. Cities did not grind to a halt under the weight of construction. They absorbed it. This suggests that transport was not an afterthought. It was foundational. Logistics was not a barrier to construction. It was an enabling system, which raises a critical observation. The scale of construction in the 19th century does not make sense without assuming highly organized transport networks operating at near maximum efficiency. Whether inherited, adapted, or developed rapidly, these systems existed, and they worked. This does not imply mystery. It implies competence on a level that is often underestimated. When we picture the past, we imagine effort without coordination, but the physical evidence suggests the opposite. Large-scale construction did not succeed despite logistical challenges. It succeeded because those challenges were already being solved. Once materials could be moved at scale, another problem had to be solved. Precision. Moving stone is one challenge. Fitting stone together, repeatedly, accurately, and at speed, is another. Many 19th century buildings display a level of precision that feels surprisingly modern. Stone blocks align cleanly, arches meet at perfect angles, columns repeat with near identical dimensions. These results are not achieved by chance. Precision requires measurement. Consistency requires standards. Standards require systems. In theory, skilled craftsmen could achieve remarkable accuracy by hand, and individually, that is true. But repetition changes the equation. When the same window proportions appear across dozens of buildings, when the same column profiles repeat block after block, when masonry joints remain consistent over vast surfaces, skill alone is no longer the explanation. Standardization is. Standardization allows parts to be produced independently and assembled predictably. It reduces error, it accelerates construction, and it appears everywhere in 19th century urban architecture. Window frames follow repeatable dimensions. Doorways align across entire streets. Floor heights remain consistent across unrelated buildings. This suggests shared templates, whether formal or informal. The precision extends beyond appearance. Structural elements often fit together with minimal adjustment. Stones sit flush. Load-bearing components align cleanly. This level of fit is difficult to maintain without controlled production environments, which raises an important question. Where did this consistency come from? Stone was cut at quarries. Bricks were produced at kilns. Metal components were fabricated off-site. For these elements to arrive ready to assemble, dimensions had to be agreed upon in advance. That implies communication, documentation, and shared expectations. Even without modern industry, this is industrial behavior, not mechanized, but organized. Another detail reinforces this interpretation. When repairs or additions were made decades later, newer sections often differ subtly in dimension or finish. The older work appears more uniform. This suggests that earlier construction phases benefited from tighter control, not looser, which challenges the assumption that standardization only improves over time. Instead, it hints that early systems may have been optimized for scale, then gradually fragmented. Precision also reduces waste. At large scale, waste becomes costly. Standardization minimizes it, and the volumes involved in 19th century construction would have demanded efficiency. None of this requires advanced machinery beyond what is visible. It requires coordination, training, shared practices, institutional knowledge. The buildings themselves record this knowledge in their proportions. They are not chaotic, they are not experimental, they are consistent, and consistency at scale is never accidental. It reflects systems that are already mature. Which brings us back to the central question. If the 19th century built with such precision and repetition, then the issue is not whether it was capable. The issue is whether we have fully recognized how organized its construction systems already were. Once precision and standardization are acknowledged, the focus shifts to the people who made it possible. Workforce. Large-scale construction is not only about materials and plans, it is about human skill, coordination, and endurance. 19th century cities employed enormous numbers of workers, laborers, craftsmen, engineers, supervisors. Historical records often emphasize quantity, thousands of workers on site, long shifts, minimal rest. But numbers alone do not build precision architecture. Skill does. Stone cutting requires training. Masonry demands experience. Structural alignment depends on judgment refined over years. These are not abilities that can be improvised at scale. Training a skilled craftsman takes time. Apprenticeship systems move slowly. Expertise accumulates gradually. Yet, in many cities, construction surged rapidly, faster than training cycles would normally allow. Entire districts rose within decades. Buildings shared consistent detailing and proportions. This suggests that skilled labor was not only abundant, it was organized. Workforces appear to have operated within established traditions. Methods were shared, standards were understood. This allowed large teams to work interchangeably without loss of quality. Another overlooked factor is continuity. Construction projects extended across years, sometimes decades. Workers did not start from zero with each building. They moved from site to site, carrying techniques with them. This creates momentum. A city in constant construction becomes a training environment. New workers learn alongside experienced ones. The knowledge spreads horizontally rather than vertically. This accelerates skill distribution. Even so, the scale remains striking. Maintaining consistent craftsmanship across thousands of workers requires oversight, coordination, quality control. Someone had to enforce standards, whether through guild traditions, engineering offices, or informal networks. This control existed, and it worked. Another detail reinforces this interpretation. Despite difficult conditions, weather, injury, limited safety measures, output remained steady. Buildings progressed predictably. Timelines were met often enough to allow planning to continue. This suggests not chaotic labor, but disciplined systems. Workforce reality does not make 19th century construction impossible. It makes it impressive, but it also challenges simplified narratives. The success of these projects depended on more than brute force. It depended on organizational intelligence, shared knowledge, repeatable methods, continuous training. When viewed this way, the workforce becomes less mysterious and more underestimated. The question is no longer whether people could build this scale. They clearly did. The question is how effectively their skills were mobilized, and why that effectiveness is often overlooked in modern interpretations. By this point, it becomes clear that the scale of 19th century construction was not limited to one country. The same patterns appear again and again across continents. In North America, cities like Chicago, New York, and Boston expanded at remarkable speed. Entire downtown districts emerged with consistent architectural language, heavy stonework, and precise detailing, often within a single generation. Across Europe, the story is similar. Paris, London, Vienna, and Berlin underwent massive transformations. Boulevards, civic buildings, rail terminals, and infrastructure projects reshaped these cities rapidly using materials and techniques that demanded high levels of coordination. Eastern Europe and Russia show comparable results. Monumental buildings, long rail corridors, and dense urban centers appeared across vast territories, despite differences in climate, politics, and available resources. What makes this remarkable is not that cities built large projects, it is that they did so in similar ways. The same construction logic appears repeatedly. Heavy masonry, standardized elements, rapid execution, consistent quality. These similarities are difficult to explain through coincidence. Cities did not share the same governments. They did not operate under the same regulations. They did not train workers in identical institutions. And yet, the outcome looks strikingly familiar. This suggests that the forces shaping construction were not purely local. One explanation is convergence. As cities faced similar challenges, population growth, industrial expansion, net transportation needs, they arrived at similar solutions, but convergence alone does not account for the timing. Many of these large-scale projects occurred within overlapping decades. Independent cities, responding separately, produced nearly simultaneous results. Another interpretation focuses on knowledge transfer. Engineers, architects, and skilled workers moved between regions. Ideas traveled through publications, exhibitions, and professional networks. This allowed techniques to spread rapidly, even before modern communication. But technique alone does not move stone. Systems do. What appears consistent across continents is not just design style, but organizational capacity. Supply chains, labor coordination, standardized practices. These elements appear everywhere. This does not imply a single centralized plan. It implies shared assumptions about how cities should be built and how fast. At a certain point in the 19th century, large-scale construction stopped being experimental. It became routine. And when routine emerges simultaneously across different cultures, it suggests that a threshold has been crossed, a threshold of knowledge, of organization, of confidence. The global parallels challenge the idea that 19th century construction was a patchwork of isolated efforts. Instead, it looks like participation in a broader transformation, one where cities, regardless of location, operated within similar constraints and solved them with similar systems. This realization reframes the scale problem. The question is no longer how one city managed it. The question becomes why so many cities managed it at the same time. And that question leads us toward the final consideration. If this level of construction was not exceptional, but normal, then what assumptions are we making that make it seem impossible today? At this point, the question is no longer whether 19th century cities were capable of large-scale construction. They clearly were. The question is why this scale now feels so difficult to explain. One possibility is that we are projecting modern assumptions backward. Today, construction is fragmented. Supply chains are global, regulations are complex, projects are optimized for efficiency, but also slowed by layers of oversight. In the 19th century, many of these constraints did not yet exist. Cities operated with fewer regulatory barriers. Land acquisition was faster. Labor was concentrated. Decisions were centralized. This allowed momentum. Once a city committed to building, it built continuously. Another interpretation focuses on inheritance. Large projects rarely start from nothing. They build upon existing infrastructure, quarries, canals, roads, workshops that may have developed earlier than we assume. If cities inherited robust logistical and organizational systems, large-scale construction becomes less mysterious. Not easy, but achievable. There is also the possibility that timelines appear compressed because we only remember outcomes. We see the finished buildings. We read completion dates. What we rarely see are the preparatory decades. Surveying, material stockpiling, skill development. These processes often leave fewer visible traces, yet they determine everything that follows. When preparation is invisible, execution feels sudden. This does not require hidden technologies or forgotten civilizations. It requires continuity, knowledge passed forward quietly, systems refined over generations, capabilities normalized until they no longer seemed remarkable. Once normalized, they stopped being documented as extraordinary. The 19th century may represent a moment when these systems reached maturity, not their beginning. And when maturity coincides with rapid urban growth, the result looks dramatic. What feels impossible today may simply reflect a mismatch between our assumptions and the historical context. We imagine the past as slower, simpler, and less organized. The buildings tell a different story. They show coordination. They show repetition. They show confidence, not improvisation. The real mystery may not be how these cities were built, but why we stopped recognizing the systems that made it possible. When attention shifts towards surface details, their deeper structures fade from memory. Infrastructure becomes background. Organization becomes invisible until we try to explain the result without acknowledging the process. If this exploration has changed the way you think about historical construction, then it has done its work. Because understanding the past does not always mean discovering something new. Sometimes it means noticing what was always there. In future episodes, we will continue examining large-scale projects, forgotten infrastructure, and architectural patterns that challenge modern assumptions. Not to replace one explanation with another, but to better understand the systems that shaped the world we inherited. Stay curious, stay observant, and the next time you stand before a massive 19th century structure, and consider not just that it was built, but how smoothly the world around it must have been working to make it possible.